Assalamualaikum. We are from Group 8 and today we will be presenting on the topic parallel circuit three-phase lines. So my group have three members, which is me, Nur Melisa Maisara binti Syahrul Nizam, and we have Nurin Jannah Irdina binti Ali Suki and also Munna Khalisha binti Abdul Jalil. So let's begin by understanding what is parallel circuit three-phase line. So a parallel circuit three-phase line refers to two or more three-phase transmission circuits that are installed on the same set of towers. So this setup is commonly known as a double circuit or multi-circuit line. So each of these circuits include three conductors, which are the phase A, phase B, and phase C. So this configuration is typically used in high voltage transmission systems, including voltage of 132 kV, 275 kV, or even 500 kV. Now, why are parallel circuit used? So there are several important reasons. Firstly, they increase the power transfer capacity. When more than one circuit is used, more electricity can be transmitted efficiently over the same path. Secondly, they help in reducing the number of transmission towers needed. So this saves space and reduces the overall cost of infrastructure. Another benefit is redundancy. If one line fails, the other can still operate and supply electricity, which improves the reliability of the power system. In addition, parallel circuits are more economical over long distance, especially in high voltage transmission where efficiency and stability are critical. So, where are these systems commonly used? So, parallel circuit three-phase lines are especially useful in urban areas where there is limited space to build new towers. They are also used along long interconnection corridors and in situations where the grid needs to be expanded without acquiring new land or right-of-way.
My name is Nurin Jannah Irdina. Okay, so now let's talk about double circuit line. So a double circuit line means that there are two independent three-phase system on the same tower. So this setup increases power transfer capacity and provides redundancy, which helps in case one circuit fail. Okay, next we move on to the conductor arrangement. So there are a few common types. First, we have horizontal arrangement. So this layout allows for easier maintenance because all conductors are at the same level. Next, we have vertical arrangement. So it's useful when there is limited horizontal space as it requires a narrower right-of-way. Okay, next we have triangular or delta arrangement. So this is a space-saving options that widely used, especially for aesthetic and clearance consideration. Lastly, ground wires are usually placed above the phase conductors. So their main role is to provide lightning protection and shielding the live conductor from direct strikes. Okay, next let's move on to capacitance in transmission lines. So first we have self-capacitance, which is the capacitance between conductor and the earth. So it depends on the height of the conductor above the ground. So next is mutual capacitance, which exists between conductors, either within the same circuit or between different circuits. So when conductors are placed together, mutual capacitance increases. These have several effects on the system. So first, it increases the charging current, especially under no load or light load condition. It affects voltage regulation, potentially causing overvoltage at the receiving end, and it contributes to power losses, which can reduce overall system efficiency. So proper spacing and configuration of conductors are important to balance performance and efficiency. Now, let's look at the impact of unequal conductor spacing. So when the spacing between conductors is not uniform, it leads to unbalanced capacitance. So this can cause voltage unbalance across the phases and result in increased power loss in the system. So to correct this issue, we use a method called transposition. So this involves periodically swapping the position of the phase conductor along the length of the transmission line. So by doing this, each phase experiences the same average capacitance and inductance over the line, which helps maintain voltage balance and improves system efficiency and reliability. Okay, so transposition involves swapping the position of phase A, B, and C at regular intervals along the transmission line. So this ensures that each phase experiences the same average electrical conditions like capacitance and inductance over the entire length of the line. So this helps maintain voltage balance and reduces power loss. However, in double circuit system, transposition become more complex. That's because there are two sets of three three-phase systems, and both must be carefully coordinated to avoid electromagnetic interference and maintain balance across both circuits.
Now, let's look at the advantages and limitations of a double circuit line. On the advantages side, it allows for higher power transfer using the same corridor, making it ideal in areas where space is limited. It's also reduced structural costs since both circuits share the same tower, but most importantly, it's offer redundancy. If one circuit is under maintenance, then the other still can operate. However, there are some limitations, which is double circuit can cause increased mutual interference, which may affect performance. They also require more complex fault analysis and protection system. Lastly, maintenance work can be risky due to the close proximity of live conductor. So while double circuit offer efficiency and reliability, they do come with technical and safety challenges. Next, this slide shows the diagram of a double circuit line. On the left, we have the layout of the base conductor on transmission tower. Each side carries one circuit labeled ABC, same also on the other side. The middle image shows a real photo how it's looked in the field with two circuits sharing one tower. On the right, we see the distances between the conductor. These distances are important to make sure there is enough electrical clearance to avoid faults and keep the system stable. Overall, this setup allows two circuits to run on one tower, saving space and improving efficiency. Next, for the conclusion, parallel circuit three-phase lines are key to modern power systems because they are both efficient and cost-effective. However, designing them isn't simple, which is engineers must carefully analyze mutual effects and ensure proper transposition. This system becomes even more crucial when expanding the electrical grid in space-limited areas like cities. So while they offer big advantages, they also require advanced planning to work safely and reliably. Thank you. And that's all from us. Thank you.